Hello friends, in this session, I will explain the basic concept of the geometric mean between two numbers along with the method how you can insert the number of geometric means between two given numbers. Let us start the chapter. If A, B, C are in geometric progression, then common ratio will be C upon B, C upon B, and that is also equal to B upon A, that is B upon A, implies that B square is equal to A into C. Therefore, B is equal to plus minus under root AC. Now we take the example. Suppose 3x and 27 are in geometric progression, then middle term x square is equal to 3 into 27, that is 3 into 27, that is 81. Therefore, x is equal to plus minus under root 81, that is plus minus 9. Now, therefore, we can see that 3, 9 and 27 are in GP. In GP, if we assume x equal to minus 9, then 3, minus 9, 27 are also in GP. Now we take the second example. Suppose x 25 and 125 are in geometric progression, then middle term 25 square is equal to first term and third term, that is x into 125, implies that 25 square is equal to 625 is equal to x into 125. 25 implies that x is equal to 625 upon 125, that is equal to 5. Now, if we put the value of x equal to 5, we see that 5, 25 and 125 are in GP. Now, suppose we have to insert n geometric means between two numbers A and B. Suppose then if G1, G2, Gn are the n geometric means and it is inserted between A and B, then this B will be n plus 2 a term. Therefore, T n plus 2 is equal to A into r to the power n minus 1. That is, in this case, B is equal to A into r to the power n minus 1, implies that r ki power n minus 1 is equal to B upon A, and therefore r is equal to B upon A ki power 1 upon n minus 1. Therefore, we can find G1 is equal to A into R, G2 is equal to A into R square, G3 is equal to AR cubed, and so on. Now we take the first example. Suppose 5 geometric means to be inserted between 2 and 128. Let G1, G2 to G5 are the 5 geometric means to be inserted. Then 2, G1, G2 and CG5 is equal to 128. Now this 128, since 5 geometry means are inserted between 2 and 128, therefore 128 will be 7th term of the series, 7th term. Therefore, T7 is equal to A into R to the power 7 minus 1 implies that in this case 128 is equal to A is 2, therefore 2 into R ki power 7 minus 1, that is 6, implies that 64 is equal to R ki power 6, implies that R ki power 6 is equal to 64, and 64 can be written as 2 ki power 6. Therefore, implies that R is equal to 2. If R is equal to 2, then G1 is equal to AR, that is 2 into 2, that is 4. G2 is equal to 2 into 2 square, that is 8. G3 is equal to 16. G4 is equal to 32. And G5 is equal to 64. And these are the 5 geometric means. Suppose we have to find the product of all terms which are in GP. It is very easy to find this product by a shortcut method. But in this case, we have to check whether number of terms in geometric progression are even or odd. I take the first example that in which the number of terms is even. For example, let the numbers are 1, 2, 4, 8, 16, 32, 64 and 128. These are the 8 terms which are in GP. It is very easy to check here that first term and the last term product of these two terms are 128. Similarly, product of 2 into 64, it is also 128. Similarly, product of 4 into 32 is also 128. And product of 8 into 64 is also 128. Therefore, if there are 8 terms, then there are 4 groups. Therefore, in this case, product of all terms is equal to first term into last term e power 4. We can also write it as rth term from beginning into rth term from last ki power 4. There are n terms in series and n is even. Then product of all terms is equal to first term into last term ki power n by 2. It can also be equal to rth term from beginning into rth term from last whole ki power n by 2. Now we take the example in which number of terms in the series are odd. For example, let terms are 1, 2, 4, 8, 16, 32, 64 and 128, 256. In this case, there are 9 terms in the series. It is also very easy to check that first term and last term is 256. Similarly, second term and 128 is also 256. Similarly, 4 into 64 is also 256. It is also equal to 8 into 32 and middle term it is equal to the 16 square. Therefore, in this case, product of all terms equal to first term into last term whole की power, since there are 4 groups, whole the power 4 into middle term first term into last term power 4 into, and middle term is the square root of first term and last term, that is first term and last term into last term whole की power 1 by 2. Therefore, in this case, it will be first term into last term whole की power 4 1 upon 2. We can also write it as r term from beginning into rth term from last whole की power 4 1 upon 2. Suppose if there are n terms in series, and n is odd, then product of all terms equal to first term into last term whole की power n minus 1 by 2 plus half. That is equal to first term into last term whole की power n by 2. It is all for today. Now I request you to subscribe my channel so that you may watch my upcoming videos within no time. Thank you.